All right, you want to get the ball? Go get the ball. Good girl. Good girl. Hello, my beautiful algebra tours. Now that you have all of that information about logs, what we're going to do is talk about the properties. And so what happens here is we have three properties. They're very, very simple. We just need to make sure that you know them. The product property is the same as with, like, let's say x squared times x to the third. Just like when we multiply we multiply exponents. Okay, when we multiply, we add exponents. Sorry about that. Let me get myself together. So that would be x to the fifth because we're adding these exponents up here. So what happens is the product property ends up being the same idea. When we multiply two things together in a log, we can expand that into an addition property with the same m and n. So what we're going to be doing is we're going to be doing what's called condensing, where we go from this to that, and we're also going to be doing expanding, which is where we go from something that looks like the left-hand side to something that looks like the right-hand side. So the properties themselves are very easy. So the product we just saw about, the quotient is very similar. So if I had x to the fifth over x squared, the rule is that we subtract exponents. And so as you can see here, that's no different. When we divide in logs, we just write that as a subtraction problem. The only one that's new would be the power property, and the power property goes like this. If we had something like log base 7 of x to the 10th, let's say, the power property just says take that power, the 10, and just move it to the front. And that's it. So it's 10 log base 7 of x. So what we're going to do is we're going to take all of these properties together and start expanding and condensing. Okay? The other thing we're going to be learning today is called the change of base formula. And the change of base formula is really for when I have no other choice to solving a log and I have to use my calculator. And that means if you look on your calculator, you only have a log button, or you have what looks like this, an LN. So the base of a log is a 10. So if it's not there, it's written to be a 10. And the base of a natural log is e. That's why, again, if you look on the calculator, the e is above the natural log, and there's a 10, let's see, look at it real quick. There's a 10 to the x above the log, and that's because they go together. So let's say I had a base other than 10. Well, my calculator only knows log base 10. We can only solve in log base 10. So if we had an example like, let's say, log base, let's say 5 of 17. So remember, if you write that in exponential form, it would look like 5 to the x equals 17. Well, who in the world knows what that is? Nobody does. So what we're going to do is change this base so that we can plug it in the calculator. So the way this is written is you'll write it as log 17 divided by log 5. And so in the calculator, you're going to type it in just like that. Just make sure you hit equals at the end, or else you won't get your answer. Okay, you should get, try it in your own calculator if you want, but you should get 1.76. If you're not getting that and you're still having trouble, tomorrow we'll go over it. Sorry about the last one, I just had to make sure you were still awake. So now that we have all our properties down, what we're going to do is expand. I'm going to do 5 and 6 with you, and then after that I want you to pause, try 7 and 8 on your own, and then come back and check it. That's the only way you learn, is to try by yourself. Alright, so in 5, what we notice is this is like our m times n on the last page. That is the product rule. And if you go back and look at the product rule, it says you can write log of 10 plus log of x. So what we're doing is we're expanding that into an addition, from multiplication to addition. Now what you do want to watch out for is, in this case, log base 10 of 10 can actually be solved, because log base 10 of 10, if I set that equal to x, 10 to the x is just 10, which means x is 1. And so over time, what's going to happen is you won't leave your answer in the blue the way it's written there. Your answer would actually be written as 1 plus log x. And again, we'll practice with that tomorrow, make sure that we have it down. All right, in 6, what you're doing again is we have a product. We have 2, which is your m, and x to the 6, which is your n. The only problem is, though, n also has a power. So we're going to be using 2 rules here. So this will look like natural log is what that is of 2 plus, because it's being multiplied, to x to the 6th, natural log of x to the 6th. Now the last step is to pull that 6 in front of where it's being we're in front of wherever it is in terms of the problem. So this is natural log of 2 will stay, but this 6 is going to come to the front for the power rule, and that would be my final answer in that case. Okay, so what I'd like for you to do now is pause the video, try 7 and 8, and then come back and look at my explanation. Okay, and to do this quickly, let's see, this will be log base 3 of x to the 4th minus, now notice how all of this is underneath the x-axis, so we're going to do this, I'm sorry, it's underneath the fraction, so this will be log base 3 of 3, and then plus log base 3 of y to the 3rd. So if you'll notice, all of this down here is underneath the fraction bar, which means it's got to be subtracted from all of that stuff. Now we're going to go through and take care of our power rule. So the 4 comes in front. So it'll be 4 log base 3 of x, that part is finished, minus, and now over here, log base 3 of 3 works the same way the log base 10 of 10 did. Without working it out, we realized that if the bases are the same, that was just equal to 1. Same thing's going to happen here. Log base 3 of 3 is just 1, and that's still in the brackets. And then this would be the 3 comes down in front, log of y. Now I know I did that fast. Feel free to watch that a couple of times if you need to. Okay, now over here in 8, I'm going to do that one in orange down here at the bottom. So this is number 8. This one's going to be technically at first, I want you to look at it as it's 3y squared all to the 1/4, so that you see that this 1/4 has to go to the front of the entire problem. Okay, so it would be 1/4 in front, and that's natural log. Now you can start breaking the rest of it down. So it would be natural log of 3, and then plus, because it's multiplication, and then the 2 comes in front also, and I'm skipping one of my steps there, but I think we've done it enough times that you can see it. Basically, I took this y squared that was supposed to be here in the second term. It was originally natural log of y squared, and I just pulled the 2 to the front. And now you're probably getting to the point where you can start doing that on your own. Again, don't freak out. We're going to practice this for a couple of days. So right now I'm just trying to get you to get the idea. All right, and then this last thing we want to do here is condense. So we're going to go backwards. So here we have separated into addition, so we're going to pull it back together into multiplication according to my rule that I learned earlier, and bam, we're done. So we take our m times n, put them back together, and we have condensed from an expanded version. Okay, so the same thing here with number 10. We have log base 5 is going to be our log. This 2 is going to come up here and make this 5 squared. So when I write this, I'm going to do my m, which is 4, over 5 squared, which is 25. And that's what the answer for 10 would look like. Okay, so same thing in 11. This 3 is going to come up here, except it's to the whole thing. It's to all of the 6x, or else it would have been split in 2 different parts. So when I write this one, it's going to be the natural log of 6x to the 3rd, and then it looks like it's times 4y. Okay, so in a situation like this, we can physically solve this. So this will be the natural log of 6 to the 3rd is 216, and I want to multiply 216 times 4, and I'm getting 864. So what I did was I just multiplied 6 to the 3rd times 4 to get that number, and then it's x to the 3rd y. So all I really did was I simplified it down just a little bit. Okay, if you haven't paused and tried 12 and 13, try it first. It's not going to be great, but then just play it whenever you're ready. Okay, so we have log base 2 here. Log base 2 of, we're going to take 625, the minus sign means division, of 125, over 125, excuse me. And then this 1/3, if you remember the power rule, comes up as, and it's times because of the addition, 27 to the 1/3. Okay, so now we want to simplify this. This is a little bit ugly. So 625 divided by 125 is 5. And then this just means the cube root of 27. You already know that from a couple of chapters ago. And the cube root of 27 is 3. And so my final answer is log base 2 of 15. Okay, and the next one, number 13, what's going to happen here is this log base 6 of 6, like we talked about before, just kind of cancels out and leaves us with 1. So we're going to have negative 1, and then this minus sign means division of, let's see, log base 6 of 2y, and then times, this 2 is going to come over here, so it would be 3x squared like that. And so I'll just write this all in one piece to begin with. So it would be log base 6 of 3x squared. Now I'm going to put that all together with just one log base 6. So I'd have log base 6 of the part that's up top, which would be my 3x squared, over the part that's in the bottom, which would be 2y. Okay, so again, you're just reading the clues. When you see a minus sign, it goes in the denominator. Plus sign means multiplication, and then the power rule can also work backwards. Okay guys, I know we've covered a lot, but we're going to finish off this really easy. This is going to be your change of base formula, and so we talked about that in the beginning, but you'll kind of get the idea. I'm going to go through them fast, and I just need you to remember what the change of the base formula is. Okay, so what we're going to do here in number 14 is we want to change the base so that it has a base of 10, so we're going to do log 17 over log 3, and I'm going to type that in the calculator and then round off my answer, which is 2.58. Okay, so in number 15, I'm going to do log of 294, which I can type in the calculator, over log 9, which again I can type in the calculator. Make sure you hit equals at the end, and you should get 2.59. And number 16, you're going to do log of 4/9 divided by log 7. Type that in the calculator, and you'll get negative 0.417-ish. Number 17 will be log 1/10 divided by log 6. Again, make sure to hit equals at the end. You get negative 1.29. All right, now what we're going to do tomorrow is practice both of those things that we talked about tonight. Have a great night, and I'll see you in the morning.